Okay, I'm hoping we talked about the back EMF in class, and let's look at 2024. All right, let's look at problem 2024 here. It says, and I'll write down the information. I won't bounce back and forth. An automobile starter has a resistance R is equal to 0.45 ohms. Okay, now back EMF, just to refresh your memory, back EMF means, let me get everything in here. And the motor operates at 12 volts, V equals 12 volts, and it has a back EMF of 10 volts. Okay, let me refresh your memory real quick on what a back EMF looks like. All right, so here um, we've got a battery, all right, here, and here we're going to have this back EMF. So this is V, and this is our back EMF. And it's kind of like the resistance inside the battery, too. There's also going to be that also. But this runs on direct current. This is an idea on direct current. But here's what happens. Now, why does this happen? First of all, we get a current started, boom, in the conventional way, which doesn't matter because if we say protons are flowing this way, then that means we've got the electrons flowing this way. So it still works out fine. Now here's what happens. It goes through this resistor R, and as this current is flowing, it's a lot of current when it first starts. But look what happens. It starts running into this back, because this is flowing around, guess what we've created? We've got a current going in a loop. So what does that create? If we've got a current going around the loop in this direction, all right, so we've got let's do right hand rule number 2. Got a current going around this direction. That means I've got a magnetic field pulling up this way. All right, I've got a magnetic field that's being induced that's pulling up this way. Well, guess what that's going to do? And when we first start up this motor and this magnetic field now is changing and it's going up this way, what's that going to do? That's going to want to create a current that goes back this way. Let's call this the I back, because it's going to create a magnetic field that wants to go down into the page. So if the magnetic field's going down into the page, we've got a current curling the opposite way until it gets to operating speed. Because this current will be changing, this magnetic field will be changing while this is changing, while they're butting heads until they've completely butt heads, and then they're at operating speed once they've butted heads. Okay, so all right, so let's take a look at what the problem looks. So there's the quick explanation, and I'll stop here and we'll go into the problem now because we've got all the information, and then we'll look at the problem.